Okay, so continuing where we left off last time, remember I left this something here, that we've designed this isotope class with these 5 pieces of data. We've got one constructor so far. We'll get to more here in a second. We've got getters. We've got a two-string method. And then we designed this decay method to then take a duration because, again, good abstraction. We don't want to have to remember that the unit was a year or a century or 5 seconds, right? We wanted an abstract notion of what a duration was. And so we brought in not a library, but it's built into the Java time library to do that for us. Now, we also noticed that we could make this a little bit more flexible, right? Before it was a void function that didn't return anything. What could we return here? And there are a couple of answers. Yeah.
An error code?
Oh, okay, like an int error code of you gave me a negative duration. I don't even know if that's possible. But yeah, you gave me a bad duration of some sort, or we've reached 0 already or something like that. However, in Java, error handling is done through runtime exceptions, right? And so that's how you would you could do C-style error handling, but that's not the Java way. Right? So what could I put here? So you're decaying it, right? You're going from, say, 10 grams down to 9.76 grams. So what's one thing that you could return? The new mass, or maybe the old, but I could always get that from the object now that it's decayed, right? Maybe the old mass or the difference between them, right? I could say double that's going to represent the how much it decayed, right? That could be useful. I'm going to show you something even more useful here, though, right? Before we do that, let me go ahead and get rid of that by the given duration. There we go, duration. All right, so I don't like the fact that this is a mutable object. Remember that we have all these getters here, right? At some point, I think we had a setter for set mass, right? That's the way that we were decaying it initially. That it goes from 10 grams down to 9.76 grams. So we computed that outside of the class over here in our demo class, and then we set the new mass of this thing. That was a bad design because it broke encapsulation. Right? So this is a little bit better design because now it's being done inside the class. But it is still a mutable object. You're still changing that object. What if I didn't change the object? What if instead I gave you a new object, isotope, that represented the new sample, right? So what I'll do here is returns a new isotope of decays this isotope by the given duration, returns a new isotope of the decayed sample. Right? Now that would mean that I am no longer mutating, I'm no longer changing this object. I'm creating a new object and giving you that new object with new parameters. What would it look like if we did it that way? I don't set this mass. Instead, I have a double new mass. Right? I'm not changing this mass. This mass is unchanged. Right? In fact, I'll prove it to you. Remember the key word in Java that we can make sure that nothing changes? In C, it was const. Right? Final. Right? Now, did anything break? Nope. No. I mean, it's still broken because I'm not done with the demonstration. But did anything break because now it's final? No. Cool, right? This now is an immutable object, which we like immutable objects because of parallel and distributed programming. Right? But I still have to take care of the return value here. So what I'll do is I'll return new isotope, where I'm passing in copies of everything. This isotope's what was the order? Element number. Element number. This dot element name, is it name? Yep, and then this dot element symbol, this dot half-life, and now instead of this dot mass, that would cause a copy of the old mass. What do I do now? The new mass. There. That's a little bit nicer. I mean, I don't want to argue that this is the correct design. This is a different design that is maybe a little bit more flexible. And in fact, that's what the whole purpose of having this, one of the purposes of having a design document and encouraging you to bounce ideas off of each other with a partner, because you can go back and forth. No, I would prefer if it were a double, right? I think that would be more useful for my use case. I prefer that it's an isotope, right? We can always compute the double later on, right? You can have arguments about that. You can have a healthy debate, right? Now, there's some obvious bad designs. For example, public. That's an obvious bad design that it goes against the rubric, right? Don't do that, right? And no, there's not going to be an persuasive argument that you can give us for it, right? All right, so sample decay. It looks like we never did our duration here. Duration 1 year is equal to duration dot of and days, minutes, what is that, of milliseconds, hours. Let's just go ahead and keep it simple, 365 days. Forget leap years. Right? Don't forget leap years for your project. Right? All right, so I'm going to, I need to decay this by 1 year now. Right? Right? How much better is that? Right? I have a generic idea of what a duration is. Now, if I just ran this, I will demonstrate to you that I'm not changing the sample anymore. Remember, it's immutable. The mass was final. What's going to happen? Infinite loop, because you're never changing the mass of that object. So the solution here is to update sample. Right? Sample will be that sample decayed into this sample. And now we've got the same behavior as before. Starts out at 10, we didn't print that out, goes down to 5 grams at the end of 29 years. Right? Okay? Lots of typing there. I don't like lots of typing. Right? So let's go ahead and figure out a way that we don't have to type so much. This is going to be called what's called a copy constructor. Public isotope that. Right? And we're not going to, don't use the variable name that. I'm just going to, I'll change it here in a moment. I just want to illustrate what I'm doing here. This dot element name is equal to that dot element name. What am I doing? I'm copying things over. This is a copy constructor. By the way, constructors are considered trivial methods and they don't require documentation, but I'm going to put documentation here to remind you that this is a copy constructor. Right? Okay? This dot element name, element number I should have said, this dot element number is equal to that dot element number, right? Dot, 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 right? Should I be repeating these 5 lines up here with that's in front of them? Is it ever a good idea to repeat yourself? That, and that. That violates the DRY principle, the don't repeat yourself principle. Right? I've got 5 lines repeated up there, 5 lines repeated down here. Let me make this constructor call that constructor. Right? This, what was the order? That dot element number, that dot element name, that dot element symbol, that dot half-life, that dot mass. There we go. All right. Now, this keyword can also be used in the context of a method, because this dot, that gives you access to that object's structures, right? But also, this gives you access to other constructors. If I click on it, it takes me up there to the other constructor. Generally, you should do that. You should have specific constructors, call the more general constructors, so that you're only ever actually doing work in one constructor. Okay? That almost gets me there, right? Instead of copying all of that, right? Then I can say this. Right? I'm going to return a new isotope that is a copy of me, of this isotope right here. Right? Except that's not what I want, right? If I did this over here in the demo now, we're back to square one. It's going to repeat infinitely because you're never actually changing it. Right? Remember, I don't want that old mass. I want the new mass. So I want everything copied except for the mass, new mass. Right? How do I do that? Right? I would really like a constructor that does that for me. Right? Anytime you find yourself saying, I really wish there was a function to do that. I really wish there was a variable to represent that. Right? What is that a signal to do? Write it. Right? So let me come up here and write another copy constructor that doesn't copy everything over. It only copies what you want over. So I want it to copy those first 4 things, but I don't want to copy this mass. I want to copy this new mass. And that means that I will take it as an argument, double new mass. There. You could call this one a pure copy constructor, and this one is still a copy constructor. It's just a modified copy constructor, right? Now let's make this a little bit bigger. Should I have called it that? No. What do you want to call it? Refactor, rename. It represents an isotope, right? And so usually it's done like that, or I for short, right? And this is why we follow naming conventions, right? How do I know that that this variable, or this keyword here, isotope and that isotope are different? Because I'm using upper camel casing and lower camel casing, and I'm doing it consistently, right? Same thing here. Again, with that trick, refactor, rename, isotope, changes it everywhere. By the way, it also changed it in my documentation. Smart IDE. Right? All right, down here, now it works. And my demonstration is back and working as well. Right? All right, copy constructors, really, really, really useful. Hint, 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 right? Not for this phase, but for future phases, you are going to want to have copy constructors because I think it's Cinco Computers. You have a product like a monitor, right? It appears on invoice A, but they bought 10 of them. It also appears on invoice B, but they bought 20 of them, right? How are you going to do that? Copy constructors, right? All right, good. I still need documentation on this. And by the way, I should probably rethink other things now that I've seen this, right? What about half-life there? Should that be a double? To do, change, double to what? Duration, right? Because, half-lives aren't always years, right? Half-lives are, some elements, they decay almost immediately. They're like nanoseconds. Other elements take billions and billions of years to decay, right? They're semi-stable. What about mass? What is that? Is that grams? Yeah, because of my output down there. Or is it kilograms? Or is it pounds, right? So to do, consider a class to represent mass, right? And it's not built into the Java language. There's not a Java mass library, right? You'd have to bring in a library to do it or whatever, right? But think about other issues here, right? Everything is a double. So what if you had a variable that it was in kilograms and another variable that was in grams and you tried to add them together? Is that compatible? Like conceptually? No, right? What if you had one that was in pounds and another one that was in kilograms? Can you add those together? No. But what if you had this generic abstract idea of mass and the same generic abstract idea of mass, and you called an add function on them, right? Right, then it takes care of all those details for you, the conversion and the adding of them together, right? So, to do, consider a class to represent mass. That is, we called that a Yagni, right, in this case, right? What was Yagni again? You ain't gonna need it, right? That's why I'm putting it as a to-do consider, okay? All right. Okay. We've gone through the first two pillars, abstraction and encapsulation. Now it is time for the third pillar, inheritance, excuse me. Inheritance basically is code reuse on a class level, right? It allows you to reuse a class by extending it and creating a subclass. Let's go ahead and zoom in on that a little bit more, right? This forms what's called a superclass-subclass relationship, or what I'm going to be calling an is-a relationship, okay? That is, a subclass is an instance of the superclass, right? Another alternative here would be the parent-child relation. Children inherit state and behavior from their parent class. Okay? Here's the design principle that we're going to be using as we go along. Right? General functionality should be located in the superclass so that it can be inherited and shared by all the subclasses. In other words, we're not going to repeat ourselves. We're going to take this stuff, this common stuff, and we're going to put it up here in the superclass. Specific functionality is located in subclasses. Right? Now, I'm going to give you a toy example at first, and then we're going to go over a real example. Animal, cat, and dog. Right? Remember that this is a relationship. So tell me which one of these is correct. Is a cat an animal? A cat is an animal? Yeah. Is an animal a cat? Not necessarily. It could be a dog or some other kind of animal, right? Is a cat a dog? Definitely not, right? Those are called contravariance, covariance, and invariance, and I'll talk about those more formally here in a second. But what I'm going to do is I'm going to show you how to do this in Java. Let's go ahead and create an animal class, a class that's just going to represent a generic animal. That's not a great design, but we're going to iterate on this. Right? Dog, right? And another one, cat. My dog, cat, and animal class. Now what I'm going to do is I'm going to highlight these, and I'm going to show you a tool that you're going to eventually be using. You don't have to use it yet, unless you really want to. Right? It's called Plant UML, and it will generate what's called a UML diagram automatically for you in Eclipse. I've got instructions on how to install it, and it's free, and it's relatively painless. If you are on a Mac, you do have to install something extra, but if you're on Windows, you're good to go with just this one simple installation, right? So there is no relationship between any of these so far. But let me show you what it looks like when you have other better, like fuller design classes, like the book class and say the person class, right? There's the relationship between those, right? Remember, it's a composition, that the book has an author, which is a person. Remember also that we made the person class comparable, right? And what else does it show you? It shows you all of the member variables. This red means that it's private, right? The green means that it is public, right? So we made everything public down here, everything private up here. It looks good, right? This is kind of what we want to see on your design document, not necessarily for Friday, right? But definitely going forward, especially for the next design document. Sketches at first. Only once you've got everything implemented would you go to Plant UML and do it. I mean, if you want to implement everything immediately and do your implementation before your design, go ahead, you're working ahead. But ultimately, we're not going to expect a formal UML diagram until after your implementation. Then you take a snapshot of this. I think you can export it as a PNG, and that's what goes into your design document, right? Plant UML, right? Now, there is no relationship between the animal, the cat, and the dog yet. What we're going to do is we're going to make a relationship. We're going to do it by using this extends keyword, right? The bad grammar, extensing, but extends is the keyword. So a dog is an animal. So a dog extends animal, okay? A cat is also an animal. Did you see what happened just there? Let me go ahead and highlight all three of them now. Dog, cat, there we go. There. They are now in an inheritance hierarchy, kind of like a family tree, and that's why we call it a parent-child relationship. You've got ancestors up here, descendants down here. Or in this case, we just have one level, so it's a parent and two children. Now, here's where code reuse comes in. The cat and the dog will inherit anything that you put in the animal class. I don't have anything in the animal class yet, so let's add something. Right? Every animal has a name, private string name, right? Every animal has, say, an age. We won't get too fancy. There you go. That's enough. Now, let's come over to the dog class and the cat class. You won't see them in this diagram, but they're inherited. They are there, right? Let me prove it to you. Let's go ahead and generate a constructor here using constructor using fields, name and age. There we go. And something just broke. Over here, the dog class and the cat class. Right? There is no constructor that specifies the name and the age of this dog. So we will generate it. Right? Now, do you see a variable called name or age other than right here on this line? Do you see it in this class as member variables? No, it's empty. But it is inherited from the animal class up above. Right? And save this, and then there we go. Do the same thing for cat. There we go, add constructor using fields. Right, there we go. Now let's open up the demo class here and get rid of whatever we were doing before. Yeah. All right, and let's go ahead and create some animals. Animal A is equal to new animal. 100. Right. Give me an animal that doesn't exist. Turducken. There we go. Oh, they do exist. Just only as a delicious meal, right? There we go. Dog D is equal to new dog Fido, right? And that dog is he's an older dog. There we go, 9 years. Cat C is equal to new cat. Cat. All right, and Fluffy. There we go. And you're a young cat, right? Not a kitten, but a young cat, right? Now, if I were to output these, say system.out.println A, B, A, D, and C here. Well, first of all, what's it going to output? Predict. Yeah, the memory address, because I have not defined a toString method yet, right? But now let's come over here to animal, and actually let's go down to dog first. And let's go ahead and generate a toString method here. Source toString, and I don't see name or age here yet, do you? All right, so let's come over here to animal instead, and let's generate it right here. Source, generate toString. Now I see name and age, and I'll go ahead and generate that. I won't get fancy about the formatting here, but now watch what happens in my demo class. Right? Did I write any toString method for the cat? Nor the dog, but by writing one, they both inherit it, right? Fido and Fluffy are able to output their names and ages because of the superclass owning that generalized behavior, right? Let me show you one more example. So let's have a public void speak method. Right? System.out.println, I'm an animal of some sort. Right, there we go. There's a speak method. Now I can come over here to the demonstration. I can say animals speak, right? Dogs speak. Cats speak. But they're all going to say the same thing. I'm an animal of some sort. I'm an animal of some sort. Right? Let's make that specialized behavior. Right? Specific behavior belongs in the subclasses. So I'm going to override what the speak method does down here in the dog class by overriding that method. There we go. And it's generally best practice to use the override annotation here. There we go. If you don't, it's okay, right? But if you do, it's better because if you misspell it, the compiler will catch you on it, right? And you're not actually overriding the speak method, you're overriding the spook method, right? Whatever it is, right? So let's spell it correct, and let's always use the override here. Now, what does a dog say? They don't say I'm an animal of some sort. They say wolf. Okay, wolf. Right? It's a big dog. Right? All right. Cats do not say wolf. What do cats say? Yeah, there we go. All right, and we come back over here to the demo. And now we see that everybody says a different thing because we've provided specialized behavior in the subclasses. But we didn't repeat ourselves, right? This toString method and the state that is common to all animals, it's in the superclass. Now this is kind of a toy example, right? I wouldn't actually write this in practice because who cares about dogs and cats and stuff like that, right? As far as object-oriented programming goes, of course, everybody cares about dogs and cats, right? But inheritance defines an is a relationship, right? When a subclass extends a superclass, it inherits its state and its functionality, which is very, very nice. Right? And by the way, I told you that I would give you instructions on plant UML. I'll put them in the notes here, but also they're in Lab 5 and they're in Assignment 2. So all you have to do is go to my GitHub page there, and I detail how to install it for both Mac and Windows. Okay. All right, let's make some observations of what we've got so far. If A extends B, then A is a subclass or a child class or derived class. B is the superclass or the parent class. And it looks something like this, right? We had this before, right? Where we've got an animal, a dog, and a cat, right? And there's my UML diagram, another UML diagram, okay? All right. Here's a relationship between them all, okay? Actually, let's come over and we can easily identify these things we already did, right? That A dog is an animal. A cat is an animal. That should be clear, right? An animal is not necessarily a cat or a dog. It depends on how you created that animal, right? It is never the case that a cat is a dog or a dog is a cat, right? This is what's known as invariance, covariance, and contravariance, right? Here's another example using birds, right? A robin is a bird, an ostrich is a bird, right? It's always safe to do covariance. In other words, you can take a robin and you can treat them like a generic bird, and we'll do that here in a second. But can you take a generic bird and force them to become an ostrich? Not if they were some other kind of bird, right? If they were an ostrich before, you made them into a generic bird, of course they can become an ostrich again, right? But that's called contravariance. Sometimes it's safe. What is never safe is invariance. Can you force a robin to become an ostrich? No. Those are all the real world examples, right? Now let's think about code. Right? You've been dealing with this at least since the beginning of the semester of CS1, right? Can you force a double to become a string? Not really, right? Can you force a string to become a double? No. What do you have to do? Double.parse double. You have to call a function that does something to coerce it into another type, right? The other classic example that we have is, say, actually, no, we'll come back to the classic example here. But let me go ahead and demonstration, right? Covariance is always okay, right? That is, I can take, I'll call it animal A2 is equal to D. What type was D again? Dog, right? I am promoting a subclass to its superclass. This is always safe. Why is it always safe? Because that's how inheritance works. That's how it's the Liskov substitution principle, right? We'll look at ways that you can badly design a class to violate this, and I'll tell you don't do that. But that's also the L of the solid principles. I mentioned that before. Single responsibility principle, and now we've got the Liskov substitution principle. We'll cover those next week, right? Anyway, it is always safe to treat a dog as an animal. And guess what? They still speak. What is A2 going to say? Yeah, it's a dog, so what does a dog say? Wolf. It didn't say I'm an animal of some sort. Why? Because it was always a dog, right? Even though I treated it like the superclass, right? Contravariance is sometimes safe. That is, I can say dog D2 is equal to A2, right? Now, Java is not going to let me do this, and this is where the classic example comes in, right? Int A is X is equal to 10, int Y is equal to 20, double Z is equal to A divided by Y, or X divided by Y. Right. No compiler error there, but what value is Z going to have? 0 because of integer truncation. What do you do to solve this? Typecast. And that's what you can do here as well. I can't implicitly force an animal to become a dog, right? Because it's contravariance. I'm taking a bird and forcing them to become an ostrich. What if they're not an ostrich? Right? So Java says, I'm not going to do that for you unless you force me to. And I'm going to force it to. Right? There. I'm going to force A2 to become a dog. That is still safe. D2.speak. Right? It's still going to woof. Right? We did bark last time in the earlier section. So, all right. Contravariance is sometimes not safe. In fact, most of the time it's not safe. So for example, what if I took that same animal, A2, and I tried to force them to become a cat? C2 is equal to cat of A2. And then I force them to speak. There we go, speak. What's it going to say? It's not even going to get to that point. What happens on line 46 here? A class cast exception. You cannot force a dog to become a cat, right? Because this is a contravariance and it's not safe, right? Because this is an invariance, right? You are forcing an ostrich to become a robin, or a robin to become an ostrich, or a cat to become a dog, right? And that's never going to be safe. So I'm trying to do a contravariance. It turns out that it becomes an invariance here. Okay. I'll make sure that you have this in the notes all the way up here. I'm not going to bother with the actual classes though, because you're not going to have cause to write a dog class anytime soon. Unless it's for fun or whatever. I guess if instead of single computers, we could have done a pet shop instead. All right. Okay. So there's our primer on inheritance. Let's go ahead and go with a demonstration now. All right. Write classes to support an asset management system. Right. We'll want stocks, right? And how are the value of stocks determined? There's a share price, and you own a number of shares, right? What else? A savings account. A savings account, you just have a balance, how much money you've put into that account. But you also get paid interest, so interest rate, right? And then, are there any other types of assets that you know about? Okay, CDs, which are certificates of deposits, right? They pay slightly better. Actually, they don't pay that much better than online savings accounts. Never get a traditional savings account. Always go with an online savings account because they're going to pay much better, right? Any others? We'll eventually come back here and fill this in, though, to see how well we design stuff. Because one of the design principles is if a new asset comes in and we have to support it, how much code do you have to change? If you only have to create that one class and then everything else works, it was well designed. Right? If you have to create that one class and then a whole bunch of other changes happen, it was probably a poor design. Right? So, I'll put that in the notes. Right? Design. What should we call this? Litmus test or what else? Sanity check. Sanity check, right? If your system is well designed, then the addition of a new type should only result in one class, right? If your system is poorly designed, then the addition of a new type would lead to many code changes that are not just in that class. Addition, right? Interest rate, sorry. There we go. All right, so let's go ahead and take care of this. Right. Let's come over here, and I'm going to get rid of the dog, cat, and everything, sorry. Right. Yay, pets. All right, let's go ahead and let's start from the bottom. Right. Let's go ahead and create a stock class. By the way, it's not stocks, it's a stock account, right? It's a stock asset. We do not pluralize our classes, okay? All right, so from the handout, what is it obvious that I need to put in there? Share price and number of shares. So private number, int or double, what do you think? Num shares. Yeah, it should be double. Why? You can hold fractional shares, right? There's some, what is it? Buffett, Berkshire Hathaway, right? The A ones are like hundreds of thousands of dollars per share or something. And so you guess you can own some Berkshire Hathaway. You'll just own 0.0001 shares, right? You could do that, right? Private double and then share price. Go. All right. That supports the state. What else would you want to put in this stock class, though? Who owns this? Owns this stuff? Stock? Answer that question for me. Private. Okay, so what if we went with a string at first? Right. What is it now? Is an owner a string? Remember, that is a relationship, kind of, right? Although it's a little bit different here because it's good modeling, right? So I could have you could identify an owner as like a UUID or a social security number or something like that, or a tax ID number. But is that going to tell me who they are or what their phone number is so that I can call them up and tell them, buy more stock, or where their address is so that I can email them a prospectus? So what should it be here? Person, I like that. All right. Okay. Anything else? Remember, when with object-oriented programming, there are three things that you need to deal with objects: identity, or state, and behavior. Behavior will come eventually. We're dealing with state right now. What about identity? What would identify a stock asset or a stock account? Some sort of ID, right? Let's just go with account number or account ID, whatever you want. All right. What type should it be? Could be an int. Right? Could be a string if you want to allow hyphens and letters and stuff like that. Let's go ahead and go with this for now. Right? By the way, what would be the real question? Like if you were doing a real system, you'd be doing something called requirement solicitation, where you go to whoever's paying for this, you have to go to them and say, what is an account number? Like, give me an example. And if they just say 123875Q, right, then you know, okay, it's a string, right? If you went to them and said, should it be a string or an integer, right? Some manager doofus is not going to be able to understand what you're talking about, right? So this is what the requirement solicitation phase is all about, sussing out what the actual requirements are. Or is it possible that an account can ever be owned by more than one person? That's another question I would ask, right? And if the answer is no, then we're good to go. If the answer is yes, then, we need to come back and figure out how that works. And by the way, they lie to you all the time, right? Because they don't know what they're talking about either on the business end, right? They're not lying, they just don't know that what the answer actually is, right? You can tell that I've had to deal with this many times. All right, so let's go with a savings account. And I am going to pluralize it because that's not the plural of savings, it's a savings account, right? Saving account? Does anybody say that? No, right? Okay. My same first two questions here, account number and owner. That seems like a savings account would have both of those. I just committed a coding sin here. What did I do? Copy pasted. Right? We're going to resolve that here in a moment. Private double balance and private double interest rate. Okay? I've got repetition between these two, even though they're the same. We don't want that. So let's create a superclass like we did for the animals. What should I call this class? Asset, okay. Or account or something like that, whatever. Right? Now what I'm going to do is I'm going to take those out and promote them up. The commonalities, I'm going to promote them up to the superclass. Take that out there. Then I'm going to put them into a relationship. If I just looked at the plant UML diagram right now, there is no relationship. Savings, stock, and asset, right? They're all just separate classes. Let me fix that by extending, right, asset, space, and space. There we go. And saving that and save, you need to save them all. All right, there we go. Save, save, and save. Come back over here. And by the way, I don't think it's true in the honors section, but in the past years I've had to show people basic computering stuff. Asset, stock, and savings. How was I doing that? Control. Windows users hold down Control. Mac users hold down Command. Right? It's called multi-select, right? And most user interfaces will support this. If you hold down Shift, what does it do? That stuff. Right? So remember your computering skills. Right? There. There is my diagram. Now, do you see account number and owner? It's in the superclass. It is inherited by the two subclasses. No repetition here at all. Specific behavior, for example, savings has a balance. Stocks don't have balances. They have share prices and number of shares. Right? All right, with our last 10 minutes here, let's go ahead and round these out. What else do you want in a class? You want constructors so you can actually create them. Generate that. Yay. Right? That breaks my subclasses. Why? Because I need to provide the account number and the owner. So let's go ahead and generate the constructor using fields. What do you think is going to happen here, though? It's going to generate it with all four of them. Right? Immediately, I'm looking ahead and thinking, oh, well, maybe I want to... no, maybe I don't. That's a Yagni. Never mind. All right. So let's go ahead and generate getters, just the getters, right? All the getters. It only generated the two that are in this class, right? What if I want the account number? What do I have to do? Well, who owns the account number as far as a class is concerned? The asset class. So let's go ahead and generate it up here. Getters. Now guess what? Do I need to repeat this stuff in the subclass over here in the stock? No, it's inherited, right? You're not repeating yourself at all. Right? So generate constructor using fields. Yay, done. Space. And finally, getters. Source, generate getters. There. Okay. Now everything is where it belongs. Savings, stock, and asset. Okay. We've got plenty of time. Let's do one more thing here. I want to know. Well, let's go into the demo and actually create these things first. I'll go ahead and get rid of that stuff. All right. So let's go ahead and create an asset called my stocks is equal to new stock. What's your favorite stock? Microsoft just went down. MSFT. MSFT. What is it? That looks right. All right. And I'm the owner, me. So I need to create myself here. Person, me, is equal to, I don't own any Microsoft stock. Thank God I don't own any Microsoft stock right now. Right? New person, me. I don't know if that's correct or not, but whatever. Right. There's me. What else goes into a stock? Number of shares and the share price. What is it? Down to 240? Something like that? I don't know. Whatever. Asset, my savings, is equal to new savings of, what's the, oh, I guess this is just the account number, right? 123 MSFT. This is 1234 big savings. All right. I'm the owner here, and I own $5.25 in my bank account. And what's the interest rate? Let's say it's 3%. That's pretty good. Yeah. All right. Now I want to get certain things. My stonks. Dot. What can I get? I can get the account number. I can get, what else? I can get the owner. There we go, me. Right? But can I get, say, the value? Dot get number of shares. And then times that by my stonk dot get share price. There we go. And that's the value. Double value is equal to. What's wrong there? In a stock class, we get num shares and share price. Sorry, num shares. It's not compiling. Why? Yeah, I'm referring to the asset. And what's in the asset class? Do you see a get share price here at all? No, I don't. And I think I can zoom in on this if you want. Where is it? Zoom. Oh, wrong way. There. So, was it wrong to treat it as this asset up here? If I change this to stock, now it works, right? But I've gone back and I've broken another one of my pillars. The pillar I've broken is encapsulation. What have I done here? I've ripped out the guts to pull out the number of shares and the share price to compute the value. The value sounds like a stock thing, at least for now. Where does it belong? In the stock class. The value of a savings account, that sounds like a savings account Where does it belong? In the savings account class. Now let's make that more generic by promoting that idea up to the asset class there. Right, let's come over here to the asset class and say, assets have value. Public double get value. Right, there we go. Now, what is the value of a generic asset? I have no idea. Right? We're going to have to fix that later on. I want to get this to compile, though. What should I do here? I can return a dummy value, turn 0.0. Right? I could return an even dummier value and return null. That's even better. Or I could say throw new illegal state exception. Right? Assets, generic assets have no way of determining value. There we go. Right? That'll work, except that it still won't compile. Why not? Oh, semicolon, there we go. Right? All right, how are we going to resolve that in the savings account, the stock class, and the asset class? We'll talk about that on Monday. Override it. Yep, exactly.